Okay. So far we have seen what is supervised learning and unsupervised learning, right? So last example which I gave where you have a room filled with fruits and you don't know the names of those fruit. Still, you'll be able to segregate them, right? Put them in a bag. Only problem here is that you can't label it. So sometimes unsupervised algorithm is also called as unlabeled algorithm, right? Because you cannot label the data. So data are unlabeled. You have the data, but you don't have the why. We don't know the exact value. So based on the characteristics, you will group them together. So here, example is customer segmentation, right? Now let's say, um, mm, you log into Amazon, right? Amazon will tell you customer like you have also bought this, or you may be interested in buying this. Now, how does Amazon know that you will be interested in buying a particular product? Okay. What logic does it use? It uses this clustering, okay, or customer segmentation. So based on our buying behavior, okay, so buying behavior could be like on which day you buy. Let's say you buy only during the first week, what kind of products you buy. You buy, let's say, only clothing, or so what kind of products you buy, when you buy, what is your price range, in what price range you buy, right? So they look at these characteristics and they say, okay, based on these characteristics, customers, and let's say if they have a customer ID. So customer C1, C55,000, C69,000, C95,000, these customers behave similarly. So let's say if all of us here behave similarly in buying the products, okay, so Amazon will segment different customer, right? Segment one. Now here there's no need to call what segmentation name, right? Whether we call group A, group B, group one, group two, doesn't matter. It's like similar fruits are in bag one. Okay. Now you don't have to call it apple, right? You just say that similar fruits are here. So if all of us behave similarly, okay, then we all be part of one group. And doesn't matter what group name you give. Generally it will be labeled as 1 2 3 4, okay, or let's say if you have to create 1000, Amazon, they have millions of customers, right? They won't be naming just 4 or 5 groups. They might have few hundreds or thousand groups. So they say, okay, if I buy something, because we all form a single group, if I buy something, that will be shown to you all as recommendation, because we say product recommendation. So it has done segmentation and then it becomes easy. Okay, whatever I do will be shown to you as the recommendation. What you buy will be shown to me as recommendation. Okay, so that's how they segment the customer. Now, if you look at Walmart, right? They have thousands of stores, right? They have, I don't know, maybe 15,000 or maybe I think 30,000 stores, right? Now, is it possible to manage 30,000 stores? No, it is not possible to manage all 30,000 stores. At the same time, okay, you will notice no two stores are same in terms of the product they buy. Okay, you can try. Okay, you go to Lifestyle in your city, to Lifestyle, they will have different kind of products. They will never have same kind of products. So products, like brand name is same, it's same Lifestyle, it's same Walmart, it could be same XYZ store. But the product that they buy is related to the demographics, the people living in that area, right? If it is a stores outside a college campus, university campus, they'll have different kind of product. Then let's say if it is in area like Banjara Hills or Jubilee Hills, will have different, right? The reason being that the people that come to your store, okay, they come with some expectation, right? Now, that expectation has to be met. It doesn't matter who you are, okay? It doesn't matter that, you cannot, you cannot sell expensive product outside, let's say, a university campus, right? Same thing, if you cannot sell cheap products in where, you have all these film stars or businessmen residing, because their expectations are different. So as a store, you have to segment your customer. Okay, okay. Now it is difficult for someone in head office, okay, there will be a buyer, okay, at head office. Every retailer has a buyer, and they're responsible for buying a product. Okay, so this, what kind of product should the store sell is the responsibility of buyer. Buyer sits in head office. Okay, if you talk about lifestyle, they'll be sitting in Mumbai. Okay, in Walmart, they'll be sitting in the Walmart head office. These buyers are responsible for a product chain. So there'll be buyer for female clothing, there'll be buyer for male clothing, there will be buyer for kids clothing, there will be buyer for electronic devices. So they'll have buyer for each of these product line, and they are responsible to understand the what do you call, like, if you are into clothing, you have to understand the fashion, the current fashion, what is in demand today, right? What is that people are liking today, and based on that, they will find the particular sourcing company. It could be outside the country as well. They'll source those products, and then they will now, so first thing is finding what will sell in the market. Okay, and then they look at their stores across the country and decide, okay, these stores, okay, these kind of products will sell. They will not send same product to all the stores. Okay, so they have to do store segmentation. We call them as store clustering. Okay, so if you have, let's say, 200 stores across India, you will segment into 10 groups or 8 groups or 15 groups or 12 groups. Okay, because managing each individual store is difficult, and managing all of them as one is not intelligent decision, right? So what they do is they segment their stores in different groups based on the demographics, what kind of products they sell, right? What kind of demographics is around, right? So that also would include the income level of people, the age group of people, all those things. What kind of taste they have. North India might have different taste, South India might have different taste of clothing, right? So they look at all these factors and then they group the store. So maybe a store in Mumbai could be similar to a store in Guwahati, could be similar to store in Hyderabad. Okay, so these stores will be clubbed as one. So when these buyers make a decision, they make a decision based on these clusters or your segmentation. Okay, group 1, group 2, group 3. Okay, group 1 could be all the stores outside university campus. They might have 21 stores across India which are outside university campus. All these 21 stores will be grouped as one. And when they make decision, okay, these kind of products should be sent to these stores, that kind of product goes to all the 21 stores. Okay, so that way your decision number of variables that you are looking at is not 200 or 300 or 25,000 in case of Walmart, but your few tens, like 15 or 20 or maybe a couple of hundred for Walmart maybe. Okay, and then they make that decision. So you are also being personalized to every store. At the same time, you're not complicating the process of thinking of each 200 as a individual stores. So that is called customer segmentation or store segmentation in second example. First example, with Amazon, we spoke of customers. You have customer and you're segmenting into different segments or different groups. Here, you are segmenting your stores into different groups. Okay, doesn't matter what name you give, right? Unlike classification, where we need to know whether there's a fracture or not, customer will buy or not, right? Okay, you have two groups. Okay, you have two groups saying, okay, fracture, non-fracture, two groups. But label is also important, right? Here, group is enough, no need to label. Okay, that's when we use clustering example. Okay, target variable is not used because there's no target variable as such, right? But it is again based on group. So it is similar to your categorical, okay, but it's not categorical. It's not, there's no name as such. So this is clustering. Then there's association. Okay, association is algorithm where you find association between two products. Okay, which two products sell more? For example, okay, if you take data science course, okay, then we can sell probably a Tableau course. Why don't you go for full course on Tableau? Why don't you go for full course on Power BI? It's like there's association between Power BI and data science, right? So we'll try to sell this similar thing. Okay, the example here is a market basket analysis. Okay, so when you go to a retail store, and this is again very classic usage in retail store, they will figure out, and we will do example. Okay, we will for each of these we will do an example in our later in our course. So we will take, okay, they take what they do is they take all the bills, okay, each bill they take and they look at the products that people are buying. Okay, so if you, let's take that you have 100 bills, okay, out of 100 there are like 30 bills in which people have bought milk. Okay, fine. So out of 100, 30 bills have milk. Those 30 bills where there's a milk, where customer have bought milk, 25 is where they have also bought bread. So what do you understand? You understand that milk and bread are strongly correlated, or there's a strongly association between milk and bread. Okay, so if somebody is and you have to do the reverse also. Okay, you look at the bill where there is only bread. So there are, let's say, 40 bills, but out of that only 20 people have bought milk. So milk to bread, okay, association is more than the bread to milk. Possible, okay, it is possible. So it's like that. People who comes to buy milk, they also most often buys bread. So what they do, they say, okay, let's put milk and bread together on the shelf. Okay, maybe somebody might forget to buy. They'll remember only milk. They'll come and pick up milk, and when they see bread next to it, they'll say, oh yeah, I need to buy bread also, right? So you are selling more. Okay, generally when you go to stores and when they give you this, right, buy one get one free, right? So that decision is also made on this. Which are the two products which are strongly correlated? Okay, if you say buy one pant and get one potato free, 1 kg potato free, probably it will not appeal to people. But if you say buy one pant and get 50% discount on shirt, okay, it will appeal to people because pant and shirt probably are more strongly associated than potato and a pant. I'm just giving you some random example, right? There was an example, there was a case where 7-Eleven stores in Japan. Japan is a very small country, right? So this 7-Eleven, what they do is like they keep rotating the products. Okay, they don't put same product throughout the day, right? Generally in a store, they'll plan for a month or 2 months, right? They'll probably change the product settings or the placement of the product once in a month, kind of. But in 7-Eleven, they change every day. Morning they'll have same set of product. Afternoon they'll change it to different because morning customers are different, afternoon customers are different, evening customers are different. So based on the customer that come in, they keep changing the product. They figured out that milk and beer was strongly associated. So, they saw that in this thing and they started putting beer in the morning along with milk, and the sale of beer increased. Later, they figured out that it was because, when they did study and understood why it's happening, they figured out that people who generally come out in the morning to buy milk or bread, okay, because for breakfast. So in the evening, they would probably want a beer can, right? They don't want to come to store again in the evening. Anyway, morning you're coming to the store. Why do you want to come again in the evening? So they'll take the beer. They will not drink it. They'll not consume it then. They'll take it, put it in the fridge, and in the evening they'll come back from office and they'll consume. Okay, but there was a strong correlation between milk and beer, and they started putting beer in the morning shelf, and they generally put beer in the evening, but they started putting in the morning itself, and the sale of beer increased. So there's association. You need to as a seller, okay, and any B2C kind of business, you have to figure out which two products goes together. Okay. So can we do that? Maybe you can give some discount and people will be interested. Okay, but not always, right? If I cannot sell two unrelated, unassociated product because that will not even appeal, okay, to the customer. So these are your 4 main algorithms, okay, and this is where we will be spending more time in our practice when we get into uh, 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 programming and creating algorithms and things like that. Then you have other things, semi-supervised, okay, classification and clustering, very similar to that. Here we are doing mix of both, okay? So when I say classification, it's probably because you have done clustering before, and now you're doing classification. Okay, second case, semi-supervised clustering, that means you have done classification before, and now you're doing clustering. So example is text classification, let's say handwritten notes. Okay, handwritten notes, I need to automate it. Okay, so you have a lot of documentation which every government office or any company who are in existence for more than 100 years, will have a lot of files, right? Papers in handwritten papers. Now, you want to automate those. You want to create an electronic version of it, right? So you need software which can read the characters and then convert into electronic A, B, C, or D, or whatever. So here you see, okay, when you do handwritten notes, there will be different ways of writing A, right? There will be different ways of writing A. So here, first you have to apply clustering, okay? Because you need to know which, okay, let's say, you have tons of characters, right? So which all are A's. First, you have to group these A's, B's, C's. Now, here we don't know it is A, B's. Like clustering is where you group them. Similar characters once, next similar characters, similar characters, similar characters. You'll probably end up creating 26 groups. And now you have to name them, right? Knowing that these characters are similar doesn't help, okay? We have to name it also. So first you do the clustering, you group the similar characters together, then you go and see and say, okay, this is A, this is B, this is C. So you're using mix of both clustering and classification. Finally, you're applying classification because you need to know whether it is A, B, or C, or Z, right? So you're applying those classification at the last. But first, you are doing clustering. Okay, so that's the example of text classification. Then you have lane finding GPS on data, right? So, GPS system, right? How do they know that it is river or flyover or road? So first, what we do is we train them. This is how flyover looks like on the map. This is how, road will look like on the map. This is how a house will look like on the map, all those things. And then when they know, okay, each of these things, so classification, they know each of those images that is on the, that comes on the map. And now it is trained that, okay, if you're on the road, you have to be on the road itself. You can't come, get into river, or you can't go to sidewalk or things like that. So again, so once they know, okay, this is how road looks like, very much like what we are trained on, right? When you're riding your car or bike, you won't drive on outside the road, right? You will drive on the road because you know that this is road, right? So now you drive only on the road, right? So first you need to know that, okay, this is road, this is footpath, this is, not road, and this is not where you should drive, things like that. And then you pick up your road and you drive on the road. So that's an example of lane finding on GPS data, where you are trained first on what is what, and then, okay, based on clustering, you keep looking for similar stuff. Okay, then we move to reinforcement learning. Okay, reinforcement learning, as I said, it's a feedback based learning where you get the feedback. Okay, so you don't get the correct answer in the first step. Okay, first time when you run, you're testing it. Okay, then you learn, and then again you come back and you improve it. Again you learn, again you come back and you improve it. Okay, so in the classification example here, you can use classification algorithm. Here you have optimized marketing. So let's say you are a marketing manager of a company. You've been given X dollars, okay, for running a marketing campaigns, right? Now, this marketing guys, they will not spend all X dollars at one go or on one channel. You have multiple channels, right? You have TV ads, radio ads, boarding, hoardings, newspaper ad, Google ads, Facebook ads. There are so many channels where you can spend money, right? But you don't know which will give you, let's say, first day in office, and you don't know which will give you the best result, right? So what you do is you will take X by 10 or X by 12. Let's say you want to do something every month. So you will do X by 12. Okay, just give me a second. Sorry. So I was saying that, okay, you have, like, you take X by 12, okay, amount, okay, and you say, okay, this is what I'm going to spend in first month. Okay, fine. So you have X by 12, but again, you don't know in which channel to spend. So first they'll say, okay, let me divide equally into 10 channels, X by 12 by 10, and you put equal amount in each channel. Then end of the month, you will evaluate and you will see which is giving you more result, which is giving you more customer, right? And that's why most of the surveys, when you go, they'll ask you, how did you hear about us, right? The reason they ask you is, how did you hear about us? They want to know which channel is working, right? So if you pick Google Ads, okay, or you say, email campaign, right? So, and they'll then going to evaluate, they're going to count, okay, which has given them more. So they know, okay, you know, boarding or paper ad actually gave us more customer. So second month, okay, it will not be X by 12 by 10. Okay. Now you will, start distributing differently. So now second month, you are distributing differently based on the learning feedback from your first month. Okay. So if hoarding gave you more result or paper ad gave you more result, you're going to spend, you have to give more budget to that. And let's say if Facebook ad was the least, okay, that gave you result. So you're not making it zero. Okay. You'll never make it zero. You will probably reduce it by half or maybe 1/4. So you are changing this allocation based on the learning that you have done. And again, this learning will be done every month. End of second month for your third month investment, again, you will evaluate. Okay, so maybe this time again paper ad came, or maybe this time something else would have come, has given you more result. So you will change the allocation based on what you have learned. This is called optimized marketing. Okay, and this is again based on the type of reinforcement learning where you are continuously understanding and you are doing it. Okay, driverless car. Okay, what you hear these days, right? Autonomous car or driverless car. These are again example of reinforcement learning. It is not possible to, okay, so now imagine yourself, right? All of you drive some kind of vehicle, right? So when you first learning your vehicle, right? They would have told you about the car, right? Did they tell you about that, when you see someone, you apply brake slowly, come down from 50 speed to 25 speed, they don't tell you those things, isn't it? You learn on by yourself, isn't it? Okay, suddenly somebody comes in front of you, you apply sudden brake, right? Because that's how you can stop the vehicle suddenly, right? So these things we learn on ourselves, right? They were taught you was a technical thing, okay? And then like, okay, red light, you have to stop, green light, you have to go, whatever, right? These are the things they teach you. But how much to stop, when to apply brake, those things you learn as you use the vehicle more and more. Imagine if somebody has to instruct you like a robot and somebody has to give you every inch of instruction. First of all, it's not possible to imagine all the situations in the world, correct? And tell you that if this happens, this is what happens. If there is a, if rain is at this speed, you'll have to put a wiper at level 4. If you're, at this speed, you have to put a wiper at level 1. Right? Those things we learn, okay, based on our common sense. Okay, so common sense is what? As you learn more, as you come across those situations, you will do automatically, right? So this is called feedback-based learning. Okay, it is not possible to write so many if-else conditions. If this, then do this, else do this. If else, if else, if else. If you start, imagine yourself training your younger brother or younger sister about how to drive. Okay, so many conditions you have to give, right? So what we do is we don't give so many conditions. Say, okay, go ahead and learn on your own, isn't it? So driverless cars, okay, that's the thing. Okay, you cannot, because if you tell 100 conditions or 1,000 conditions, there will still be some conditions where it is not possible to train, and then machine will not know what to do. So instead of being dumb, you want it to be intelligent, right? So cars are being made intelligent because they will give this condition feedback. Okay, if I don't stop, this is what happens. If I don't, okay, do this, this is what happens. And based on that feedback, the cars will be able to make its own decision, right? If I don't stop at red light, I'll go and I'll cause an accident, or I'll be involved in an accident, and that accident probably will have a negative value of -1,000,000, let's say, for example. Okay, so I don't want to get -1,000,000, right? So something like that you have to program so that your cars are able to know what is right, what is wrong. Okay, what is right, you give higher points. What is wrong, you give negative points. Nobody wants to get negative points. So you will be able to learn. So this is again feedback-based learning. If I do this, this will happen. Oh no, I don't want to do this. Okay, if I do this, this is going to happen. Yes, I want to do this. Then you will do. Okay, so driverless cars are again designed, or being designed based on this in reinforcement learning. Okay, so these are the algorithms. I told you these are the family of algorithms, right? These are not the algorithms. Again, within these, you'll have multiple algorithms, right? So far, so good?
Yes.
Okay, great. Now we will go down, okay, to our programming world, and we will start, okay, doing or um, uh, start our coding. Okay, try to implement these concepts. Okay, so let's go and check. Okay, so again, see, before you perform, okay, so let me go to the next slide. Okay, so what is data science? Data plus science. So you need to have data and need to apply science on it. And again, data science is not about just science, there's an art also. Okay, I say like Tableau, Power BI, these are like art, right? How well you represent this data. So it is data plus science and also art. Okay, science and art both are important. So for now, we're going to talk about science part, which is algorithms. And once we are done, okay, I think most of you have already done Tableau, Power BI, and we will again revise, we'll revisit Power BI. Okay, okay. So these are some examples like stock market price prediction. So tell me, okay, what you have seen so far, right? Mainly, we have seen three algorithms: regression, classification, and clustering. Association, of course, but that has a different usage. Or let's say we say four: regression, classification, clustering, association. Now, which, if you have to make stock market price prediction, right? You want to predict the price of your stock, what it will be after, let's say, end of 15 minutes or end of 4 hours or whatever, right? Which of these four you think you should apply? Which family of algorithm do you think will be suitable here?
Clustering.
Supervised.
Supervised learning. We have historical data for it.
Okay. So see, supervised, unsupervised at a higher level, right? Okay. So yes, it is supervised learning, but in supervised learning also you have two things: regression and classification, right? So here it is regression because you are predicting the price. Price is a dollar value, right? Continuous numerical value. It's not a group. Classification is group. Clustering is also group, right? Okay, just that you have a group name and you don't have a group name. Okay, but here it is regression, right? We have to use type of regression because you're predicting price. Price could be $12.59, okay? 111.11, right? It could be any amount, isn't it? So price of a stock is a number, right? So we have to use regression concept here, okay? Spam detection. You have all of you must be using Gmail. Even all this email has spam, non-spam, okay? So the emails that come to your inbox, Gmail is going to read it before you read it, okay? And based on the content, it decides, oh, it looks like a spam. So it puts in the spam folder. It looks like a good email. You put it in inbox. So what kind of algorithm do you think you'll use there?
Text classification.
Others? Yes, it is classification, right? Because one, you need to understand group A, group B, right? These are similar emails, At the same time, you have to label it also. Just because it's no, you have to say that this looks like a your spam. Okay, so it's like fruit, where segregating the fruit. Okay, but you need to know the name because you have to label the bag also, right? Just by grouping is not enough. You need to label the bag. Oh, this is spam and this is not spam. So this is example of your classification. Recommendation systems. Clustering, because you need to group the two people together, right? Same thing we discussed in the examples also. Okay, Amazon recommendation system, because you need to know these kind of people belong to similar group, and we don't need to know the name of the group, not required. Okay, just need to know these are the people who belongs to this group. Now you use that knowledge to recommend. Okay, that's an example of your clustering. So thing is, when you look at the problem, first of all, you need to decide. Okay, is it regression, or because association is different, altogether different thing, right? So it'll stand out. Okay, but you need to understand whether it is clustering or classification or association or regression, right? When looking at the problem, that's when you need to proceed. Okay, and maybe there are a lot more examples, and you can think of those examples first, and then try to think which will be useful there, which algorithm will come in there. Okay. Now, what we do as part of data analysis, what is the life cycle of data science, data analysis, right? Machine learning. So first thing that we do is getting the data, right? Get the data, right? Data can come from multiple sources. Okay, it may be in CSV file, maybe in the database. Okay, it could be in multiple sources. So first of all, you need to get them together and have them in a single format. Okay, you can't have multiple format data and getting into system using multiple formats. Get them into a single format. Okay, and that role that people that they do is called data engineers. Their responsibility is to connect to various sources, get the data, put them together, get the relevant data, right? Okay, you cannot perform analysis on. Okay, so it's like this: garbage in, garbage out, right? If your data itself is garbage, your result, whatever you use, doesn't matter. You'll get garbage out only. So getting the relevant data is important. Okay, so before that, okay, that's why I say is always, for that matter, any okay, step 0 is understand the objective. What is the business objective? Okay, understand the business objective. What is that you are expected to do? What is your role? Okay, for example, stock market prediction. Okay, so I'm required to predict the stock market of, let's say, Tata Motors. I'm just saying one example. Okay, and for how many days? It is for for one day. Okay, what is going to be the stock price? Okay, by end of tomorrow, let's say. Okay, so that's your objective. Now you know that, okay, you are looking at predicting stock market, or you're looking at the stock price of Tata Motors. So you need to know the past data of Tata Motors. What was the price? How did the price move yesterday or day before and before and before? Then you get the data, right? I need to know how far behind in the past should I go. 1 day data is enough? Probably not. 2 days? Probably not. 3 months? Yeah, but we can go, few months back as well. Okay, 6 months, 1 year. Okay. Okay, so say, okay, 1 year data is good enough. So then you say, okay, I need Tata Motors data for 1 year. Now, if your objective is to predict the price at the end of the day, okay, then probably last 1 year opening and closing prices is okay. But if your objective is to predict every 15 minutes or every half an hour, what will be the change in price, you need same level of data. Okay. So when you go back to the previous data, you need the data at that interval, right? 15 minutes interval. Opening and closing may not be sufficient. So this is where, you need to first understand, okay, objective and get the data. Okay. Very critical, because if you do not get this right, it's like this, you want to go to Delhi, okay, but you are on a road that takes you to, let's say, Mumbai. It doesn't matter what you do, right? Doesn't matter how super fast car you buy or what you do, but you will never ever end up going to Delhi, right? So this is like, if you do not get this, this is like getting into the ocean, right? So you are on the track to get into the ocean. You will go to ocean. So before that, okay, you have to work hard, talk to different teams, your businesses, understand what they need, and get the right set of data, whether it's in terms of columns, whether in terms of rows as well, right? What um, uh, that's what interval of data you need. Okay, so once you have this, that's when your work will start. So first step after getting the data, which is step number 3 here, is to make sure that data that you have is ready for analysis. Okay, so when you get this data, you can have some missing data. Data could be outliers, right? Let's say you are predicting marks and you see that there are some marks more than 100%. Okay, if there's some marks more than 100%, definitely it is not possible, right? You need to remove, you need to treat those data. Okay, we'll see. Should you remove or not, we'll see later. But you need to, that we have to treat the data, right? Data treatment is required. So we call this as pre-processing. Processing is your model building, because that's why you are here. Okay, so it's called pre-processing the data, making the data ready for analysis. So okay, the most common thing is handling the missing values. Okay, you don't expect data to be available for all rows and all columns. There is some missing values. So how do you handle those missing values? How do you handle the outlier values? How do you handle the incorrect values, right? So these are the things that we are going to do in pre-processing, which we will see. Okay. Okay, once your data is ready, your pre-processing is done, your data is ready, then you decide, okay, we perform what is called as EDA. Okay, EDA we have done for some of you, have not done for some of you. EDA stands for exploratory data analysis. Okay, exploratory data analysis. Okay, exploratory data and DA. Okay, now this is your data analytics part, basically. Okay, you want to see the relationship between different variables. Okay, you want to see the different, you want to predict recommendation system. Okay, you want to do the customer segmentation. Okay, and one factor is the average cost of products bought by customer. Now, average cost of products bought by customer, does it impact the decision? Does it impact your main objective? Okay, or not? How do you know, right? You may not know. So, we use scatter plot, box plot, your bar graph, pie chart, etc. Okay, all these are we use to understand the relationship between the data. Okay, to understand the relationship. Visualization. Okay, data visualization is used here. Okay, those we have not done, we'll come back and we'll do it after that. This machine learning is done. Okay, we'll do that. Okay, that is important because that will tell you if there is a relationship between two variables or not. Okay, what we are doing, okay, are they like, is it garbage in, garbage out? Okay, so in our course, when we are going, when we do these things, right, more than visualization, we'll focus on the statistical value. Okay, we'll see. One is visualization. You see and you will get to know what's happening. Second thing is by statistical method. So mostly we will be using statistical method. So that's why, okay, EDA we won't be doing much. Okay, but when we do projects, okay, towards the end we'll do 8 projects. 8 projects, we will spend enough time on doing EDA. Okay, EDA is just plotting different graphs. But before that, you need to know which 2 variables should I use. Okay, I need to know the correlation between, okay, regression. Okay, in regression, correlation is very important, right? You have x's and y, single y, multiple x. So the first rule, what it says is x, okay, should influence y. That means y should be impacted by x. There has to be some correlation between x and y. If x is not correlated to y, that means x has no impact on y, then that x is not required to be part of your machine learning, right? See, I need to know, okay, how much marks I'll get. For example, Okay, in in board exam. And swimming, for example, number of hours you swim, let's say, has no impact on the marks I'll get. If number of hours swimming is not impacting, okay, impact could be both positive or negative. So swimming is neither impacting positively nor impacting negatively. Then why should I include that? That column is not required, okay, to be used. So before you perform regression, you need to understand, is there a correlation between X and Y? Okay, so swimming is not correlated. Drop that column. Swimming number of hours swimming, that column should be dropped from analysis. That will not be part of, that will not be one of your X. Okay, so that's one thing. So you need to check the correlation between X1 or Xn and Y. Okay, otherwise drop it. Second thing is, within X and X, okay, within X and X, there should not be any correlation. Okay, because if within X1 and X2, there is a correlation, X1 and X2 are dependent, okay, and both of them have correlation with Y, then we don't have to take both, even one is enough. Okay, example could be, if you are predicting number of cars, okay, now number of tires, we know that it is 1:5 or 1:4 or whatever. Then no need to predict number of tires, isn't it? You predict number of cars, and that is enough for you to do all the calculation. Okay. So we also have to see the correlation between each of these x's. X's should not be correlated. If your x's are correlated, that means one of them is enough. Whichever has higher correlation with y, you put it. Other one, you drop it. Okay, it's like this. If I am going somewhere and I know, okay, let's say I'm going to talk about the problems we are facing, okay, to whatever board, uh, um, to say government authority example, okay, the problems I face and problems you face are same. Then one of us goes, it's okay, right? We don't need to be like, both of us need not be there together, right? Because our problems are same. So whether you go and talk or I go and talk is same. So if X1 and X2 both are correlated, that means they are related to each other. Okay. So one of them is enough. So these are the things that you will check in EDA. Okay. Correlation between X's. There should not be any correlation between X1 and Y. There should be correlation. Otherwise, there is no point of including that column. So these are the things that you do in EDA. You're trying to understand the data better. You will know the data better in EDA. So now you know, at end of step 3, what needs to be used, okay, for your machine learning. So once you do the EDA, now you use the right columns, okay, that are selected for your analysis, and then you build the model. Then you build the model. Building the model is applying regression or clustering or classification. But again, this is not as simple as it looks. Okay, building the model, what is the first step you can think of? Dividing the data into training set and test set. I briefly spoke about it yesterday. You need to divide your data set into training set and test set. What is training set and what is test set? Okay, I told you, right, in each of these algorithms, okay, family, what I refer to call it, I refer them as families. Okay, regression, they have multiple algorithms. Which algorithm within regression is best for this kind of data, right? Different algorithm is suited for different types of data. Which algorithm is suited for this kind of data? We don't know yet, right? So we need to test the model, right? You need to test the model. So if I am the teacher, what I'll do, I will ask you questions to understand who has understood the topics better, correct? And which questions will I ask you? Will I ask you the questions for which I don't know the answer? No. I'll ask you the questions for which I know the answer, isn't it? Then only I'll be able to judge you, right? So what I'll do, let's say if you have, 100 rows of data, okay, and these are your all x's, okay, x1, x2, x3, whatever, and this is your y. So what I'll do, I will take 20% or 30% of data, okay, I will hide it from you. Okay, so for example, if I know 100 concepts, I will teach you 90 concepts. 10 concepts I'll hide you. Why? Because I want to test you on those 10 concepts. Because if I teach you all the 100 concepts, then I won't be able to test you, isn't it? So this is 100 concepts. So I have hidden these 10 concepts from you, 10 rows of data, 10, 20%, 30% of the data. And you say, okay, algorithm, regression 1 or regression 2 or regression 3 or regression 10, regression 20, whatever. Okay, this is the data. This is your X and this is your Y. Now learn it. So we did discuss yesterday, right? That in machine learning, we give input and output. The learning is based on input. There is no formula. Formula is what machine has to derive from X and Y. So we say machine learning, train, learn. Okay, learn means derive that formula. This is your X and this is your Y. X and corresponding Y. So now machine says, yes, I have learned it. I'm ready. It's okay. You're ready. Now let's come for a test. So what will you do here? This, you have this 20% data, right? So you will give X to the model. So, okay, now that you have learned, these are the questions, these are the input. Use your formula that you have derived here and predict me the Y value. And you have hidden this Y, right? You are not showing this Y to the model. Okay, this is the answer which I know, right? And then you will ask the model, okay, now that you have understood from here, now that you know the formula that you have, each model will have different formula, right? Because they are designed differently. Okay, so you say, okay, fine. Now you predict it for me. Okay, so this is training part. First part is training part where based on the input and output data, machine has learned, okay, and has come up with its own concepts. Okay, it has come up with its own formula. Okay, now you say, okay, take this X, okay, and predict for me. So machine will predict. This becomes we call it as, let's say, Y pred. And we call this as Y test. Okay, so this entire Y will divide into Y train, Y test, X train, and X test. You pass X test to the machine or model. Okay, and model will give you this Y pred output. And this is the actual output which you have hidden from the machine. Now you compare this output. Okay, so what we just did, we first, okay, created training set and test set. Okay, train and test set. We just created train set and training test set. Okay, we created the data set, then we ran the model. Okay, actually execution, right? This is just one step. Running the model is the easiest of the thing. Okay, what is important is what you do before that and what you do after that. Okay, running the model is easiest. So divide and train, test, and run the model. Okay, now you get the output and evaluate. Okay, it's called model evaluation. Evaluate each model which has done, which you have used. Okay, so evaluation is compare how, this is the actual answer. This is, okay, where is my, yeah, this is the actual answer, right? And this is what model has given you. Okay, if actual answer is 5, model says 4, there's error of 1. Other model gave you 5.5, the error is only 0.5, isn't it? That means the one that gave you 5.5 is a better model than one that gave you 4, isn't it? That's what we say model evaluation. So evaluate the model and you pick the best model. So yesterday I gave you example, right? For quiz competition, you have to send. So you figured out who is the best student or in business quiz. Okay, so this is like picking up the best model. Okay, you have given same data to all the models. You have run the model. You have evaluated. Based on evaluation, you figured out this model 3 is giving you least error. All model will give you error, right? When you want to predict, prediction is never right. Okay, all model will give you wrong, but we're looking for model which is giving you least error, which has got it least wrong, correct? And that is your best model. You pick up that model and okay, use that in the production environment. Okay, then you say for this kind of data, this model is best. Okay, so then you deploy it. Okay, evaluate. Let's say evaluate is a different. Okay, so we will run the model. Let's say here, build the model, run it. Evaluate, we'll put it in step number 5. You evaluate and pick the best model. 6 is deploy. Okay, put them in real use. Okay, so these are the 6 steps that are required. Okay, and then once you deploy it, again, this is a this is cycle. Okay, you will again evaluate, is it meeting the objective or not? You started with, okay, meeting the objective. Okay, now you keep evaluating. I have created an algorithm to make stock market prediction. But okay, once I decide and when I use it, okay, the next day I will have the actual answer and model, how the model has done. I'll evaluate. Okay. And if I say, oh, we are very close to the prediction, I'm happy. I'll use the same model for next day also. But if there is a totally wrong, if I got it totally wrong, I will again redo the same process. Okay. So you redo it till you are happy. And once you're happy also, you cannot, be satisfied, because every day you have to evaluate and see. I mean, in this case, every day, in some cases, every quarter, every month, every year. Okay, depending upon, the usage and the kind of algorithm that you are using, you will evaluate and come back and, redo. Okay. So these are the steps that we will perform. Of course, objective and getting the data. Okay, we'll assume that you got it right. There's nothing wrong here. From pre-processing to model selection, and towards end we will also see how to deploy. Okay, we'll take one example and we'll deploy on cloud. So, okay, so but here pre-processing to picking up the best model evaluation is important. Okay, now pre-processing is same for all machine learning algorithms, whether it's clustering, classification, whatever, it's the same. But model evaluation is different, right? Okay, evaluation will differ because the output is different, right? So we'll see how to evaluate a clustering model, a classification model, or a regression model. Okay, so these are the steps. We'll stop here, and next time when we meet on Monday, we will